All right, welcome everybody. Week 15, day one. We're going to be handling some miscellaneous topics today. So I've taken requests from the students online right now. We got requests for hitboxes, jump scares, AI spawning, and Simon. I am currently reloading the level with water enabled, so that's going to take a little bit of time. So let me talk about, I guess, hitboxes. So in video games, a lot of times we don't use a particularly accurate hitbox. Like, we'll actually just use a box sometimes. So the human body is not box shaped. So that creates an area here and here, right? Where the bullets will hit, and then you get hit, and you're sad because you shouldn't have been hit. But usually you can't tell because if you're getting shot, like, you don't know where they're aiming exactly. But like, if you have any game that has like a laser pointer, so like you hold down the button and like a laser dot appears and you trace it over that area between their head and their shoulder, the red dot will appear in space right here, and that looks pretty bad. So there is a collision system called a capsule that is half sphere, half cylinder, and you can see the hitbox is not especially accurate here as well. Now, what you can do is when you do like a bullet or something like that, let's see, let's just go to the third person character blueprint. When you do a trace line, the frame rate is tanking again. Oh man, I really need to figure out what's going on with this. Okay, so normally you just care, like, did I hit something, you know? And it will normally just give you the hit actor, that's the person we hit. But if you want, you can do things like, what bone did I hit, and the name of the bone, and things like that. So that's useful for like intersecting with skeletal meshes. And so you can make it so that like heads do double damage and things like that. So the hit system does have more accurate collision for skeletal meshes. Generally speaking, I don't worry about it. For me, a headshot is anywhere like up here, you know, like up here maybe it's a headshot. But yeah, hitboxes, like if they're not accurate, like people will get mad about it. A lot of the meshes that come in with Unreal Engine don't have a collision generated on them, and I think I made one for this one. Yeah. So what you have to do is is you have to go into the collision tab, and you can just generate a convex collision for them if they don't come with one. So there are these things called simplified collisions, and so if you put on a simplified collision, you can see that it will just wrap a box around the whole thing, and that's fast. Usually, you know, there is a speed penalty for doing more accurate hitboxes and things like that, but you could just like add a capsule, you know, add a box, add a sphere, and the system will automatically sort of wrap it in such a way that it'll be okay. Like, it's not going to be great, but the nice thing about simplified collisions is that they're fast. You can remove all the collisions off of it, and then add a 24 degree of precision thing, and then that's like, you know, pretty good, I guess. Like, there's still areas where like you'll see bullets, you know, hitting. Do auto convex collision. Let's see here. Yeah. So yeah, you can play with those settings. So basically, you know, you can just sit there and look at it, and hole count. So with more holes, we get a fairly accurate, you know, collision on here. So that's unfortunately something you have to do for a lot of things, because they just don't come with the collisions enabled on them. So yeah, the basic rectangles and stuff like that, sure, yeah, they have collisions on them, but a lot of the meshes don't come with a collision, and so you have to generate them, and it's kind of annoying. Okay. Hit boxes with animations. Yeah, so same thing. Like you just grab the bone that you collided with. Okay, how to make a jump scare. All right, so let's say that you want to jump scare somebody when they come in here. They're trying to get the vaccine or whatever, and this guy, you'll see this guy up here. He's got a cool little shadow. He's running around. You're like, there's a skeleton up there. I have to be careful. But you want to like jump scare him, like bam, like you walk in here and like maybe you check, over here because you suspect there's something behind the staircase, because that's the thing they do in a lot of games, right? Like, there's usually a secret back there, right? You can see the light fade also because this is global illumination. So maybe we make it so that like when the player like sticks his head back here, like a zombie will spawn behind him. Okay. So we'll drag out a trigger box and just kind of move it around a little bit to the right area that we want the jump scare to come out in. Bigger. Kind of like that, I guess. So if the player walks into here, maybe let's just make it right exactly like here, right? So like when they kind of nose into the back of the closet, trying to see what's back there, that's when we're going to spawn something over here. Okay, so we're going to take this trigger box and we're going to convert it into a blueprint, and we're going to call this jump scare blueprint. Jump scare BP. We will save this into the build directory. I don't remember. Do I have a blueprint? Do I have a blueprint directory? Nope. Okay, it's just the root build directory. Okay. So scary time. Yeah, I mean we should have done this for Halloween, right? But, okay, so we got this thing, and now probably want to have. How should we do this? We can do this a lot of different ways. We can have the zombie already in the world, just hidden, and like not activated or something. We can activate it. So, or we can just spawn an actor. Okay. We could have a point in space where it'll spawn a zombie. That might be the best way of doing it. It's like maybe we can have like, how we have these target points for like, these jump pads here. Like they have a target point, right? So maybe like our jump scare thing could have like a target point, and then when you enter the box, it spawns a zombie on the target point and then deletes itself. Like, does that work for you guys, or was there something else? Like I'm pretty open ended. Like whenever I teach this class, like I basically love taking requests and just doing things. So you got to tell me, like, does that sound about what you had in mind, Victor? Like you walk into the box and then behind you the zombie spawns, maybe. Well, can it run across the screen? Oh yeah. See, I was thinking like the Doom 3 jump scares where like you stick your head and then there's a loud noise, you turn around and there's something there that wasn't there before, which really annoyed me about that game like a lot. But you want it like flying at you, like a loud noise. Okay, so you want it like flying at you. Okay, all right. Let's do my version first, and then you explain it. Then I'll make your version second. We got plenty of time today. So all right, let's come back in here, and we will make a very little. Called the Tarzan. Make a target point reference and make it world visible, and this will be called the spawn point. And maybe we can make a variable like the entity to spawn, but maybe we just hard code it as a zombie and worry about that later. Okay, so on begin play, you can do this, get spawn point, and if like spawn, so there's a thing called is valid. And so like if the person making the map has forgotten to set the spawn point, then if it's not valid, then we just be like print string error, You forgot to set the spawn point on a jump scare BP, you noob, and then we'll just like remove ourselves from existence, right? So like basically if the map maker forgets to set the spawn point, we'll just print a die, and these things only appear in development mode, right? So you don't have to worry about it like going out and, oh, I don't know, submitting homework that has egg in it a bunch of times. Ramirez. Okay. Yeah. So let's do this. Let's just make sure that works. So compile. So isValid is a really useful function that just tells you if the error you forgot to set the spawn point. Good. So it's a really useful function that if if an actor or whatever is not set, then it can tell you if it's set or not. So that's super cool. I'll just leave that in there. That's fine. And then we want the event overlap here. And we want to say when the player overlaps us. So cast to third person BP, boom. Q to line them up. If it is not the human, we don't care. If it is the human, then we will start off by doing print string as always. Hello. Just making sure this works. Aha. That's why we do this. Connect that. Don't forget. Run. And we'll run over here. Oh, didn't trigger. I might have missed it. Bro. All right. And then I'm just going to double check. Do you have generate overlap events turned on? Generate overlap events is on. Okay. Let's check where it is in the world. Okay. Save it. Compile it. Save it. Run it. Send it. All right. Zoom back over here again. Huh. Let's just put this right here and just make it a little bit bigger. Not doing anything. Oh. Yes, it's because it's deleting itself. Right. Hoisted by my own petard. All right. So let's make it. It's doing exactly what it told me to do. It's destroying itself. Okay. All right. So target point. Yes. Target point. Here we go. And we'll just put the target point here. And then I'm going to click on this guy, use the eyedropper tool, and select that target point. So when we walk over the zone here, it will spawn something eventually there. Not just yet. I'm just making sure it works. Did not work again. Did it print anything? It's not printing anything. Let's just turn this off for now. To begin overlap. Why is that? Died. Oh, I see. Yeah. Yeah. I don't know. What is this doing? Begin overlaps on cast a third person character. I wonder if that is like string. This is the fun part of Unreal Engine development. It's not fun. Like, why is it not doing something? Nothing. Not generating any events. Huh. Generate overlap events is on. Set as a trigger. It's just not generating a event. Did something on the player. Time remaining? No? Okay, that worked. Time remaining 20 seconds. Bruh. And that worked. Okay. Bruh. There, that worked. So the player is generating overlap events. Why is this not generating an overlap? It's a trigger box. It's a trigger box. Well, there's one simple trick we can do. The doctors hate. We'll delete you. Delete you. We will start zone. We will delete. We will duplicate you, and call this the jump scare. BP. So we'll drag you out to here. Move it up a little bit, and we'll just verify that it's triggering. There we go. See that triggered? I don't know what's going on. It's just the same thing. It's a collision component. Trigger generates overlap events. Event graph, begin overlap, BP third person character. I don't know. Okay. Let's check one other thing. I'm just going to put these side by side. I don't know. You got me. All right, so I'm going to delete the other one. There. All right. Maybe. All right. So I don't know what went on with that, but okay. So anyway, we're back where we were before. So we've got our trigger box. It's going to trigger, and then what we wanted to do is spawn a zombie on the thing. So we want to have here a target point, object reference, open, and this will be the spawn point. Save, compile, and then we can add target point back out here. And you can have it appear over their head. That'd be funny. How about that? Like drop out of the sky. Yeah. And then I'm going to link them together by clicking on the blueprint, clicking on the eyedropper. Where are you? There we go. Eyedropper, and picking that point right there. Now they are linked together, and now I will go back to, again, play, and pull this out, and get, and say is valid, is valid. If it's not valid, then we are going to play a sound. Bruh. If you forget to... and then we'll delete ourselves. Okay. So the thing is not set, then it's going to say bruh and delete itself. But otherwise, it'll be good. And then when you come over here, I'm just going to print to the screen. Hello. Sure. Yeah. Save here. And there it goes. Prints hello. All right. So take that out. And, I could edit this out of the video of me, not be able to figure out why that's doing it, but no, I'm going to leave it in. So you can see what the debugging process looks like too. Okay. So we can overlap there, and now we're going to spawn a zombie. Okay. So the way of spawning something is spawn actor from class. And the class we're going to spawn is a zomboid, zombie VP. And this is going to answer the question of one of the other students, how to make a jump scare and AI spawn. Because you're going to see this isn't actually going to work, but you'll see what I mean. So we're going to spawn a zombie VP, and we're going to pull out the spawn point, and we're going to get its transform, which is its translation and rotation, right? And then we put that in there. So basically, when the player walks over it, it's going to get the location of the spawn point and the rotation of the spawn point. So we can have the zombie spawn in different directions if we want. And it will then spawn a zombie, and then we are going to play a sound, some sort of spooky sound. Let's play it in the speakers. Sure, go with that. Okay. And then we'll just destroy ourselves. Okay. So basically what this is going to do is it'll one-time spawn a zombie.
Bruh. Bruh.
Accessed. See, this is what I was telling you. It's not going to work because we're spawning the zombie, but we're not spawning the brain that goes with it. Okay? And so the execute ubergraph zombie brain BP blueprint zombie brain BP access none. So let's see if we can find location of this. So this is zombie brain BP. Right, and so the trouble with this is, and this is a common problem, right? Where anytime you spawn like an AI, the controller needs to be set on it. So we spawned a zombie, but it doesn't have a brain set properly, and so that's why we get all these errors when trying to read the brain of the zombie. So let's see if I can remember how to do this. So, see if that'll do it. It's been a while since I've done this. So. Or zombie brain attached to a non-zombie. That's funny. Okay. Same problem. All right. Trying to do. So, that's a zombie BP.
Red. A second. Yeah, I mean, I remember setting this back in the day, right here, when you create a pawn, then it should normally the default here is placed in world, which is why the zombies work, but we set it to place in world or spawned, and so it's supposed to automatically possess it with the zombie brain BP. And the weird thing is that it's actually kind of working. I mean, the errors aside, you know. Like when we do this, the thing is appearing, and then it's, you know, it's like kind of working. I mean, it seems to not really be getting a lock on us like the other ones do. But like it's moving and stuff, you know. So I don't know. I'll need to figure that out. It's an issue I always have. Whenever you spawn AI, it's just an issue. Like where the AI just like breaks for some reason. So I'll have to get back to you on that one. All right. So another question we had was, why is water weird looking? And the answer I kind of went into in the water lecture, and that's the defaults are really bad. I mean, bad for like most people, right? And so they'll create these like lips and things like that, where the ground raises up, it lowers down. You put the water on flat ground and it raises a channel around it, and you ultimately just have to play with the settings. So the there's settings for like adjusting the angle and the width and the fall off and things like that when you have a river selected, and then you can also move the control points for the spline up and down and kind of have them more flush with the ground level. If they're above ground level, then it'll pull the ground up towards them like this. And then, yeah, I don't even know what's going on with that thing there. It normally will just carve that away. So you can try, again, pulling the water up and down a little bit. There are occasionally weird tears and things like that when you put the water next to a lake and things like that. Okay, so let's see. You wanted a jump scare where, like, you open a door, you're supposed to grab something, you don't grab in time, you'll be jump scare, an image appears on your screen with a jump scare sound. I see. Okay, so let's do that next. Then I'll try and figure out why that stupid guy is not working quite right. It's supposed to have like a collision zone there too. Bruh.
Oh, weird. Um, okay, so if you don't pick up something in time, then you get jump scared. Okay, so how about we use the timer code, right? Where like we do this and the time's running out, and if you don't pick it up in the 20 seconds, then it will jump scare you by, what did you say, display something on the screen and a jump scare sound. Okay, sure. All right. So we could probably just do that with what we have here, honestly. There. that's your jump scare, right? So the if you go back and look at the lecture for doing the HUD, instead of it saying you died, then just put a jump scare of a cat or something on the screen and play sound, and you're good. That's all inside of the UE main HUD thing here. And there is a image called dead image, DED image that I made, and it defaults to hidden. And so if we set it to visible, which is what happens in the thing. So there's a function here, and we go to the function for it. Or it might actually just be in the player somewhere. Yeah, wherever that is. Tag. Place. Create med. Add to viewport. Okay. Let's see. Maybe it's under U. Set story style. Okay. Is that not used anywhere in here? There it is. Okay. It's the downside of working with blueprints is that it's somewhere. All right, so it displays mission survive, and then if the time remaining is less than 0, then sets the visibility on the dead image, sets the opacity to 1, and then we just add in a jump scare sound here as well. So if you want to see how to make this thing, go back to the lecture on making a HUD, because it's basically the jump scare that you're looking for, right? So what you do is you create a widget or you make a HUD or something that you add a here. So you drag out an image like that, and just put the image wherever you want the jump scare to be. The image you can I don't know, whatever. There, boom, scary. Look at that scary thing. It's like the music video for Got Ya, the girl I used to know. Okay. So like basically that will appear on the screen. Why? Why will it appear on the screen? Well, because by default you're going to set the visibility to hidden or the opacity to 0. One way or the other, it works for me. And then when you have the jump scare happen, you set a variable, and then inside of your function for it, you set the visibility of it to be visible. You set the opacity to 1, and then you play a sound. I'll just have it play bro. Like that. And there's your jump scare. So does that make sense, Victor? That's kind of the 30-second explanation of it, right? So you go into the HUD designer, drag out a picture, and then have one of the different bindings you have check to see if it's time to do a jump scare, and if it is, you turn it on and play a sound, bruh, and there you go. So now if we run this again. 20 seconds left. And then when it runs out, did I die? Like at the last second? That's unfortunate. Okay, let's try that again. Bruh. I'll just wait in here. So when the time runs out, it'll display the jump scare. And then it's supposed to play the sound. Why did it not play the sound? Main HUD. Graph. Because I didn't select it. That's why. Okay. Oh, there you go. One more time. Let's do that. Save, compile, save, run. And come over here.
Bruh, 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 bruh.
Gonna run for the hills. Okay, all right. Yeah. So this thing doesn't actually disable itself after that point. So it's just infinite bros. That's funny. I'm gonna leave that in. That's a great bug. Okay. So just infinite bros. Okay. Any other questions for today? Good. I'm glad that you want to take your mouse to a river and bam, filled with water. Yeah. So yeah, the splines are not quite as easy to work with. You can kind of almost get there. Like with a height map, you can kind of paint height maps, like this kind of stuff. The mountains you can paint. But as far as rivers go, then you're just kind of stuck working with a control point. So, all right. So let's do that river. So we want to add a river over here somewhere. Does it enable? Yep, there we go. It's doing something. Yeah, basically, to mess with the splines, you alt drag and pull out additional control points on the spline and then move them around and adjust their Z values. The river object as a whole controls the fall off settings and things like that. So things like the channel depth, the ramp width, the fall off is the main thing I play with. Those are all the things you need to mess with in order to get the river looking decent. It out of the box, it is kind of okay, but it's not great. So, there we go. There. Right. So like over here, you can see it like elevated that land. And just like completely obliterated the lake and stuff down there. So click on you. Click on you. There we go. I'm going to move that spline point back away. And you can see how it like generates land like that. That doesn't look very good. So I'm going to lower it down to here. And on the worst thing I've seen. It's not great though. You can see the river is kind of like flowing into my static lake now. It's okay, I guess. So yeah, if you want more controls, control points, you can alt drag that. And then you can have these things kind of go in all sorts of different ways. It's kind of cool looking, I guess. I don't know. Doesn't look that great though. Really too pinched. Can you make a boat that floats along? Yeah, there's a buoyancy system. Ew, that doesn't look good. That does not look good. Yeah, so basically, there's a whole tutorial that you have to go through on it. You can add buoyancy components to like a boat, and then it'll provide like upwards force for the physics and things like that. I haven't looked at that in a long time though, so I can't do it off the top of my head. I can prep that for next time though if you want. Buoyancy is pretty cool though. Kind of happy with it. Yeah, I like that. Okay. Any other questions? So yeah, like I said, you just kind of have to play around with all these like, you click on the river and then you click on the different fall off settings and things like that to get it to cut into the landscape properly. So if you want to have like realistic water, then you have to like actual like physics water. Then you have to use Niagara water. So let's see if I have that even on here. Yeah, but there's like Niagara systems that will like actually generate water that will actually flow around rocks and things like that. It's quite expensive though. So one more thing, how do you change the water color? That's a good question. Let's see. Okay, so there is a material on the rivers and things like that. So you can browse over to it if it is browse to it. Okay. So this is in the so when you install the plugin, there's a folder within a folder within a folder here, and you can switch out the different materials, or you can edit them. So this is water material river. So you can click on that, and you can change the colors and things like that inside of there. Okay. So basically you click on the river, and then I just search for material here, and then this is the different materials for like river to lake, river to ocean, the water material, the that, and you can see all these different settings here you can mess with. So there. And that. So if you want to do like a candy river or something like that, yep, you do that. For AI spawning, is there a way to make it like Call of Duty Zombies, where they spawn a certain amount at a time and increase the longer you play it? Yes, you can. So for example, I just spawned a zombie, and again with the pawn possession thing is like a constant annoyance. You can use that spawn actor thing however you want. So for example, you could have a timer that fires. Maybe it creates one zombie a second, or something like that. In fact, we could probably just repurpose this one here. Timer start zone. Go away. Go away. Go away. This is auto possessed. I don't know. I'll figure it out. All right, so we're gonna spawn lots of dumb zombies, I guess. Get lots of error messages. All right, so when the person begins overlap, we spawn the actor. We can also do something like this. We can say create a timer, new timer, make a timer. Where's my timer at? If you're a timer, where would you be? Timer. Why is that not? Oh, there it is. Okay. All right. So, so we can set a timer, and every 3 seconds looping. After a 5-second start delay, it will trigger an event, and the event will be a new event. Custom event called spawn zomboid. And what will this do? Well, it'll just spawn an actor. So VP. Spawn point not set. I don't know what is going on. Alright. It's set. Alright. Crashed. Infinite loop detected. Yeah. Fair enough. Oh, right, because it spawns one zombie. Right. It spawns a zombie, then it destroys itself. Okay. There you go. Infinite zombies. There we go. Okay, and of course the brain issues there, but yeah. And then you can change things like the speed of spawning, right? So this could be a variable, and the variable promote to variable, and this would be like, spawn rate, like that. And maybe the spawn rate starts at like, I don't know, every 5 seconds or something like that. And then after like a minute, maybe we spawn another timer. Start timer. Yep. Set timer. Okay. Then maybe we have another event with the callback. It says click add custom event every time it goes faster. Okay. So every, I don't know, 10 seconds, looping, this will get called, and what this will do is it will get the spawn rate, subtract 1, and then feed the result of this into clamp. And so the maximum spawn rate will be 5 seconds, the minimum spawn rate will be every 0.1 seconds, and the results of this will be set spawn rate. That. And so basically every 10 seconds, the spawn rate will go from 1 zombie every 5 seconds and 1 zombie every 4 seconds, 3, 2, and then it doesn't drop to 0, it drops to 0.1, so we don't have infinite zombies. And you'll just get zombies out your ears after a while. So there's 1. There's 2. I don't know why it thinks this is a non-zombie though. Zombie brain is attached to a non-zombie. Why is that? Why is that happening? The computer club meets second Tuesday of every month on Discord here at 12. Today's not the second Tuesday. It's last week. I'm gonna die. Anyhow, so that's the idea. So you can see it'll slowly get faster. Every 10 seconds, it'll spawn faster and faster and faster. You can also have like a variable that holds the max number of zombies, and so if the number of zombies drops to 0, then it spawns more zombies, something like that. Yeah, it was a week ago. So okay. Any other questions? Simon game. Yes. Yes, let's do that. Okay. So, and I am no longer going to spawn zombies. We'll just cut that right in there. No more zombies spawning until we figure out what's going on with that. Sweet. Zombie game. Simon game. Perfect. Let's do this. Okay. So, you thought Monday was Tuesday? Yeah. Okay, so how should we do this? A Simon game. I keep saying a zombie game. A Simon game. Zombie Simon. A Simon game. Okay. So, So we want the computer to generate like a random sequence. Let's just say 4 lights, just to throw out a number there. So we'll need to have 4 different objects out there that we can like have glow or not. We can do that with like an emissive texture. So we can have that be a dynamic texture that we could like have it glow. Okay, so let's start off with that. Let's start off with just like a glowing red, like something. Okay. Yeah, like right. It's like we have it be green, but then it becomes glowing green, right? And so let's sketch out some stuff. What shape is that? It's like a, it's like a torus that's like broken, right? Torus. Yeah, we'll just make some squares and not worry about the modeling for now. Okay, so we'll just have a cube that we shall flatten down to walk on, and this cube shall be called red. I don't know. So we're gonna need 4 of them. All right. So I'll drag out. These are maybe a little bit too tall, actually. Squishing down a little bit. No. Scale 0.1 and snap that down to the ground. That looks about right. Okay. And then I'll drag it out. Drag it out. Drag it out. And just to make okay, so it's now the Windows logo. Or it will be. All right, so I'm gonna actually name these different cubes. Maybe. You know what? I need to. I need to make these into a blueprint class first. Okay. So we'll convert this to a blueprint class and static mesh actor. Okay. And this will be called Simon Says Blueprint. It's going to be stored in the build directory. So static mesh actor, that should work. I'm still a little bit paranoid after the previous thing not working. Okay, so to you, we are going to add a box collision. And the box collision will be a box. All right. And then we'll come over here, and on begin overlap, we're just going to print string, because I'm now completely paranoid after it didn't work last time. So we'll do that. File, save, snap it up here, run. Over here. Hello. Okay, that worked. I don't know. I just haven't had enough coffee today. That's, yeah, half a thing. All right. So we got that working. No worry about the modeling. Yeah. He thought sorry to say red. Yeah, red's the name of one of the regular users on the Discord. So I was trying to see if I could make a joke that would stick, but oh well. So so when they begin overlapping, then we want to call a function on the player. The question is where the game is going to reside, right? Do we want to have like a game blueprint that then this thing talks to it, and every time you step on it, it sends a function to it? We could do that. It's doable. We could just have it on the player again. It's also doable. How you design these things is kind of up in the air. I think what I'm going to do, though, is I'm just going to save this for a second, and I'm just going to add a... I like how it's called a box collision in one place and a trigger box in another place. Alright, I'm just going to make this big, and I'm going to make it so that, like, when you... This is going to be, like, for the game. Okay, so, like, when you walk in, it's going to start the game. This might not be the best place for it, but whatever. Okay, so this will be converted into a blueprint, and this is going to be called Simon Says Game BP. So I'm going to have one blueprint for the game, and I'm going to have one for the, and again, I'm paranoid about this now, so print string. And I'm going to have one for each one of the things you can step on. So we walk in, hello, great, neat, hello, cool, hello. All right. So, so when you walk in, Simon Says begin now. Okay. And I should probably make this a little bit bigger. Move it away from the rest of the area. So you just don't walk over by accident. Just put it over here. Okay, so this will be the Simon Says zone. Maybe I'll flatten out the landscape there. It's like it's on a very slight incline, which looks a little bad, but fine, I'll do it. Smooth. And then it's better. Flatten. There we go. There we go. Okay, so when we walk over this thing, it's going to print Simon Says begin now. And when we leave, we're going to turn off the Simon Says game 2. And so we'll probably want to have the ability for the player to just quit, you know, by like... I'm going to probably do something with that. So I'm going to add an event actor and overlap. Thank you. And then this one, for now, we'll just say print string. Simon Says game over. So what I'm doing is I'm just making it so that when you walk in here, it prints Simon Says begin now. You walk out, Simon Says game over. So if you like, I could probably use that Niagara effect actually. And just define the region using that giant particle beam there. But okay, so that's good enough for now. Okay. And so what I'm going to have is I've got these Simon Says BP and Simon Says game. Okay. So I want the game to know about red, blue, green, and yellow. And so I'm going to just have some Simon Says references inside of Simon Says game. So it knows who it's So because this is gonna be the brains that is gonna cause the things to like turn on, right? So there you are. There's red. All right. So we've got red coming in here. All right. Functions, variables. Okay. So we're gonna have 4 variables. One called red, and this one is gonna be a Simon says BP, and then that'll be world sendable, and we will duplicate it for green, and for blue, and for yellow. And what we're going to do is, after the game begins, we're going to start turning these things on, and then the then when you walk on them, it's going to report back which ones you touched. Wait, you were actually called here? Yeah, I was actually just talking about you a second ago. You just randomly walked in red. That is actually kind of funny. All right, so we'll do the game in a bit. For now, let's get these things set up. So we got red, and this one is going to be named red. And then we're going to drag this over here, alt drag. And then this one is going to be called green. And I'll drag this one over here. This one is going to be called yeller. And I'll drag this one over here. We call them blue. And I probably should have named them better, so they're all next to each other in the world outliner. I'm going to call this one. Actually, I don't want to call it SS yellow. That sounds like a ship. Yeah, maybe that's okay. Okay, the SS yellow. Simon says yellow. Wait, no, that one was supposed to be blue. Shoot. Okay. This one is Simon says blue. This one's going to be Simon says yeller. This one's going to be Simon says green. And this one's going to be called Simon says red. Now, when you click on them, they're all next to each other, so it's a little easier to organize. I could create a little category. Maybe I'll do that. Where's the... Okay. So I can put all the objects from Simon Says into the Simon Says folder. Simon Says game, and we'll rename this Simon Says. Okay, so now all the things in the world outliner are all like in one place, and so you just like click on that and select them. You can hide them, things like that. So that kind of makes the organization in the outliner a little bit easier. I don't know if you guys have seen that before, but it just makes it easy. You can like pin it and stuff. Okay. So what we want is, first of all, we need to make a material that will glow. All right, so we're gonna have to make a dynamic material with a material parameter on it. Okay. And then we need to make it when they walk over it, it reports the walk over to the game, and the game's going to need to highlight things. So those are 3 things that have to be done. Probably the easiest is doing a material. So we've done this before, remember, with like our material instances and things like that. So quarter material noise parameter. Let's see here. Maybe we will just make a new material. That might be the easiest. And this will be called Simon Says Material. base color is going to be a parameter, so we're going to have a parameter, vector parameter. And this is going to be called color. And we're going to hook that up. Metallic should default to 0. Specular, roughness, let's just give it a default value of just like bright red. Why not? And then the emissive shading model. Let's see here. Lit, unlit. See if that needs anything. Default lit, subsurface, clear coat. Should be fine. Blend mode. Fine. Okay. Okay. So the emissive color is also going to be a vector parameter. We're done duplicate vector parameters. It confuses Unreal Engine. This is going to be called the emissive color. And by default, it looks like plastic already. So I think we can just kind of leave it in the default, thing. Do you guys want to add a normal map to it? Like, let me, does that, I mean, it looks pretty smooth to me, honestly. Like, do you want to add like a little bit of stippling or something, like a little bit of texture to it, or is just perfectly smooth, like a little too, maybe too bright? Okay, let's try this and slap it on one of these guys. So Simon says material, and so if you have a material selected and an object selected, if you click the little arrow, then it will just apply it. That doesn't look exactly red though. That's kind of more of an orange color. Maybe that's okay. I don't know. All right. Okay, and the material, if we try different colors, I mean, honestly, I think that's kind of okay. Like, that's like a glowing green, so, yeah. Okay. And the emissive, I think, is, yeah, I'm wrong. Yeah, works for me. Okay, so that's that, really. Okay, save. I think, yeah. I mean, we could add a normal map, but honestly, it's just smooth plastic, so the default material you get is really, I mean, it really just is like smooth plastic, you know what I mean? It kind of looks a little artificial because it's so, like, I feel like with a normal map, it might look a little bit better. So let's pull it from here. Texture parameter. A little bit of modeling on that. Anything with an underscore n is a normal map. Mannequin normals, Unreal Engine normals. That's funny. Where are we at? Underscore n. Water. Maybe that one. No, too much. See that? There's like, do you see what I'm getting at here? Like, just adding a little bit of like roughness and irregularity to it makes it a little less like in your face. I think it's fine.
All right. So we'll do a world aligned normal. Pull that out. Right click. Z normal. And so this is your homework assignment, by the way, is to make something with world aligned normals and world aligned textures. Texture size, I will pull that out, and that will be a vector parameter. And this is going to be like normal map size, and it will default to like half a meter, like that. 0.5, 0.5, 0.5, and then we should have a nice little bit of roughness in there, maybe. Legitimately not seeing any normal map on that thing right now. So I'm just gonna just use a regular normal map. It's fine. The tiling's not going to look great. See here? The tiling's not going to look great on the sides, but this is not what we're here to work on right now anyway, so good enough for now. Okay. So we've got our material set. We need to make a material instance of it, create a material instance, and this is called the SS material instance. Why not? And slap that on there. It looks exactly the same. Cool deal. Save, and then we just put on all of these, I guess. All right. And so what we're going to do is when we are red, we set ourselves to be red. When we're blue, we set ourselves to be blue, green, etc., etc. So Simon says BP, so we're going to need the begin play node, and we can do something like so I'm going to print the names of all four of these things. SS blue, SS yellow, SS green, SS red. Cool. All right, so come over here. So get rid of that, get rid of that. And so branch. Actually, we can just... we can make it enum for this. Might make it simpler. So I'm going to make it an enum, and so basically description, colors for Simon says, display name is going to be red, green, yellow, and blue. So why am I doing this? Well, I still might do it. What I could do is just have a bunch of branch statements, right? Like, do it like a comparison, branch, like if my name is double equals to,
if my name equals, you know, red or blue, then do this, and I'm probably still going to have to do that. But what I want to do is actually just have a variable holding, you know, essentially 1, 2, 3, or 4. Am I red? Am I yellow? Am I green? Am I blue? Because that'll make kind of the coding easier later on, rather than constantly having to check your name, you know, to see what your name is. So, okay. Or green, yellow, blue, and yeah, that's fine. Okay, save. All right, so we're going to make a thing over here, and our variable is going to be a Simon says color. Says colors. Okay. Okay, and this is going to be called my color. All right. So this, we'll do a string compare equals so if the string equals SS red, then we're going to have a bunch of these things, right? So if our name is SS red, then we're the red one. Maybe there's a better way of doing this. There is a better way of doing this. Okay, I don't want to do this. This is annoying. Instead, I'm just going to make this instance editable, right? Which I did actually already. And so what I can do is just the person who's making the map can come over here and just click on that, and they can choose where are you? It's PP. SS colors is variable and public. Okay. Compile. Thank you. And there it is. Okay. So the top left one is going to be the red. The top right one over here is going to be the green. The bottom right one over here is going to be the yellow, and the bottom left one over here is going to be the blue. So now I don't have to go through that annoying process. Just the person who's making the map can pick which one of the 4 it is. If I really cared, I could have like a different setting, like a different material instance for each one of these, but I don't care. It'll change when the thing initializes. So when we begin play, we will do what's called a switch on my color, SS colors. Thank you. And so if my color, there, and so this is what I'm telling you. Like it actually makes your code layout a lot nicer, because there's 4 possibilities. I'm the red one, I'm the red tile, I'm the green tile, I'm the yellow tile, I'm the blue tile. So rather than having to do that stupid annoying string comparison every time, this works, right? So we don't even care what the name of the thing is anymore, which is good because those change, right? So for red, then what we're going to do is we are going to get our material instance. We can see how that's done on this thing over here, dirty wall. So what we do is we, on begin play, we get our material and create a dynamic material instance and set it. Okay, so we're going to just do the same thing here. So on begin play, not you, not you, not you, maybe you, maybe you, maybe after. Okay, so we are going to get material. Nope, I don't think that's tied into anything. Get material. Yeah, okay, not, doesn't have a white thing here. So get material of our static mesh component. Okay. And so this is going to get the material off of it. And then we could save that. Do we need that? Do we care about that? I don't think we care about that, honestly. So we are going to turn this into create dynamic material instance out of it. And that takes a white thing here. And that's going over here. Let's go over here. And you're going to go into there. Okay. Target self element index 0. Okay. So that is going to get material 0, which is the only material, which is this one, element 0, right? So this is going to get the thing. It's going to turn into a dynamic material instance, which allows us to change the color in code. Okay. So we've gone over dynamic materials before, but hopefully this will help refresh your memory a little bit. So when we begin playing, we turn our material into material instance. We then switch on the colors, and if we are red, then what we're going to do is we are going to set its parameter, set material, set scalar parameter value. Yeah. Do we do that again? I guess we do. Yeah. Okay. So let's move this over to the right a little bit more. Right click, promote to variable. And this is called my material. And then we will set the material on us. That. So we get our material, we turn it into a dynamic material instance, and then we set it like that. And we need to reroute node here because this is very confusing. Double click and drag. There we go. Okay, so when we begin playing, the thing turns its glowing red thing into a dynamic material instance and sets it again. And then we say, hey, who are we? And then we're going to change our color based on who we are. If we're red, it'll become red. If we're green, it'll become green, and so on and so forth. So what we're going to do is we are going to, what's it called? Color. Okay. And emissive color. All right. So, does not like. Create a dynamic material instance. Does it require the thing? Yeah. So the material. Interesting. Create a dynamic material instance. Not on a primitive component. Okay. Two different functions with the exact same name. I love it. All right. So we begin. We begin. It creates a dynamic material instance. Set it. Set material. Switch on SS colors. Okay. And so before we even do the switch, let's just see if it works. So what we're going to do is use set scalar parameter value. Actually, we're going to do set vector. Set vector parameter value. Parameter name is called color. And we're going to set the color to be just green. So if this works, and we're not doing anything with the switch yet, I just want to see if this is going to work. If it runs, it'll all turn green. There we go. You guys see that? So in the editor, it's red. But when it runs, it is going to set the vector parameter called color. We're setting it says XYZ here, but it's RGB, right? We have a parameter called color, and we are setting the color on this material to be green. Okay. So So then we're just going to do that, but after the switch now. Always you want to test to make sure your code works before you get too far into it. So, so if it's red, we're going to set it to be, actually we don't need to, it's already red. So if it's green, we'll set it to 0, 1, 0. Duplicate. If it's yellow, do you see how nice this is? You have an enum. It's actually really, really convenient. You, parameter name, color, and we're going to set you to yellow is full red, full green. Duplicate. And you set blue to be 001 RGB. Okay. Now, if we did this right, we should get the Windows logo. Crash. Set vector parameter and material show. All right. All right. Maybe we do need a red. I don't think that's the problem though. Crash. Switch on SS colors. Infinite loop detected. Okay. Ah, yes. The output of this node right here, break pin links. There we go. That's our problem. All right. Run. And here we have the Windows logo. Sweet. All right. 250. All right. So I think that's enough for today. So that is how I would begin doing it. We'll have to do the coding next time, which is fine. We got a few weeks left in school anyway. But basically, what I did to summarize was I made a blueprint class for the individual tiles you're going to step on. I made a blueprint class for the game, and the game is going to use the dynamic material instances to cause them to glow in different colors. And then when you walk over these things, it's going to report back to the game, hey, I stepped on red, I stepped on blue, I stepped on green. Right now, all they're doing is when the game begins, it turns its mesh into a material. It turns the material on its mesh into a dynamic material instance, and then it is setting the color parameter on them based on whether or not it is set to be a red, green, yellow, or blue. And that red, green, yellow, or blue thing comes about from right-click making a enum. Enums are great if you have a limited number of options for something. You make an enumeration, and you can pick between them. And it just made, like, I was like not looking forward to having all those string comparisons and stuff like that. So as you can see, it works nice. We just need to get the glowing going. If you want to see it glow, I can do that real fast here. So let's just make the green glow, I guess. Let's duplicate you. And so if you want to see how to make something glow, it's not called color, it is called emissive color. So we'll just Control C, copy the name. If you don't spell it exactly, it will not work. So be careful with these things, and I'm going to set it to glow with the strength of 100 suns. It does not like you because I'm not pulling over the box. Okay, there. And so you can see that that one is glowing, right? So there's some light coming off of it. And it's as simple as that node right there. So we're just setting we have a material and we're setting the parameters on it. That's why it's important, even if you're just a programmer like me, and I don't really like do art stuff, too much. It's still important to know how materials work and things like that because they all tie together, right? So whoever it is that's making your materials, will expose parameters like this, where you've got a color parameter, a emissive color, and then you, in your code, you can actually change those values. So you turn the material into a material instance, and then you can set the, different parameters on it at runtime as you touch things. They can glow and not glow and things like that. So pretty cool. So we'll pick this up on Thursday. Thank you guys for coming out. And your homework for today is to just do the world align textures, and that was the other half of the lecture from last time. It's I wanted you to do the slightly harder thing with the water over the weekend. You've got 2 days to do it, and world align textures and world align normals are really easy. The video that I uploaded got eaten by OBS because I've been having issues with this new build. I finally got it stable, at least, but OBS ate the recording, so I had to re-record. And the good news is it made it a much shorter lecture, so you can find that on the IS50 playlist. So go ahead and just make some walls and things like that blend together seamlessly using world align textures and world align normals, and that's all you got to do for Thursday. Am I recording MP4? I'm recording in MKV format, and it's not a problem that I had otherwise. It's literally just a problem with the instability coming from enabling the XMP profile on my RAM when the RAM was not capable of running at that high clock speed. So I've gone through 5 boxes of RAM and finally have one that works. So yay. You go, G-Skill. All right. The homework is water. Not water, just the world align textures. So that was the other half of the lecture from last time. You can see the video. It's only like 5 or 10 minutes long. It's not very long. Yeah, it's up. All right, guys. I will see you on Thursday. Peace out.